Good evening. When I was asked to give this talk, my hobby is in mathematics, and it struck me that from very early school to where I am now, I was born in 1950, you can do the maths yourself, an awful lot has changed. And when I was first at school, the emphasis was on doing calculation. And what the national curriculum, even now, is saying, it mentions the word calculate 10 times for key stage 4. It's a sort of key element. A lot of it can be pretty tedious and dull. And when I first started out, we used to do things with long division, possibly is still taught. And what's one of the problems that might be set for me to do was something like this. Gold bar. And what I was asked to do was to find out its diameter if it was a sphere. So it gets remelted, gets recast as a sphere. What size would it be? It might be that the teacher had an idea that he would break in and remold all these gold bars and roll them out. I don't know. So what did I need to know? Well, one of the things I needed to know what the weight of it was, so it's 12.4 kilograms. And that in itself, I need a bit more information. And the other bit of information I need to know is what the density of gold is. Well, it's 19.3 grams per cubic centimetre. Now, with that information, you can calculate what the volume is. If you've got the volume, you can calculate what the diameter of the sphere would be. So how I would start out, let's just take working out what the volume is. We had to do this calculation, 12,400 divided by 19.3. Now, if you are adept at these sort of things, you might start thinking of quick wins. One of the things you could do, if there's a common factor to either the denominator or numerator, you can get it smaller. Unfortunately, 193 is prime, and so you're stuck. You're stuck with doing the long division. And so you proceed in this way. You set it up, you put 193 on there, you divide that into the first number, you get that's 6, that's 1,158. Are you all familiar with this? You know, I'm getting nods and cheers, and you go on doing this, and it would take you a bit of time, but as you got down to the bottom of it, you would find you've got the answer, and put back the decimal point, and so we've now got an answer, 642.487. It's quite hard work. You can do it in pencil and paper, but it's hard work. And the next thing to come my way was this chap, John Napier, and in 1614 he published a paper, a Mavifica Logarithm Canis Descriptio, a description of the wonderful law of logarithms. And what he wrote about it was this. He said, "Since nothing is more tedious, fellow mathematicians, in the practice of the mathematical arts than the great delays suffered in the tedium of lengthy multiplications and divisions, the finding of ratios, and in the extraction of square and cube roots, and in which not only is there the time delay to be considered, but also the annoyance of the many slippery errors that can arise, I had therefore been turning over in my mind by what sure and expeditious art I might be able to improve upon these said difficulties." So if you've done this at school, you'll be familiar with it. What he did was, I'll give you a quick refresher. 16 by 8, okay, you know what the answer to that is. But you can do this in a form of logarithms. You can express 16 as 2 to the power 4, 8 is 2 to the power 3, and if you subtract the indices, you take 4 from 3, you get 1, and that's 2 to the power of 1, and that of course is 2. So that's how logarithms work. Apply that to our problem. There's our problem. And we take the log, we're using base 10 now, instead of base 2. We take the log, and that's 5.093. 193 is 2.286. And here is his clever bit of thinking. It's now a subtraction. So all I need to do is subtract one from the other, and that's quite easy to do. I get 2.807, and take that back, and I get the answer 64249. Now you might say, well, where do you find out what the logs are? Well, every school child of my age had a set of log tables, like these. If you were a bit pretentious, you had the Cambridge elementary mathematical tables. And if you really were a geek, you had something like this, which is 7-figure log tables. And they are, I don't know if I can open this up, they're all full of numbers. You go to the right page, you look up what the numbers, go across the tables, find what it was, you put it in here, you do your addition or subtraction, and then you'd find your the antilog of that, and you get your answer. All good fun, but taking a huge amount of time. So, after that, you get your answer. Next thing that came my way was the slide rule. Now, slide rules these days are not very common, and I still have a few at home, but I have to say I rarely use them. And all they did really was to mechanize the log tables. On the ruler, it's divided into logarithms, and so by either sliding it along and reading underneath it, you could either add, which would be a multiplication, or doing it the other way, taking lengths apart, it would be a subtraction, and hence a division. Next thing to come my way was calculator. Bliss. Absolute bliss. All that hard work. And you're familiar with calculators. You've got bound to have one. If you've got a phone, you're bound to have a calculator on the phone. You might have more than one calculator on your phone. And here, all you need to do is, as you know, you key in the number 1,200, divide, hit 19.3, equals, bingo, there's the answer. And who would want to go back to doing it the hard way? Certainly. So that's the one thing that happened. Coming along also over the horizon was the spreadsheet. And here, what you could do is you could put that number in one cell in the spreadsheet, the next number underneath, and then in the box underneath it, you simply said divide box A by box B, and you get the answer. Again, a very, very simple thing to do. But then things have moved on since then. And I don't know if you've ever tried this. What if you typed that calculation, 12400, divided by 19.3 into Google, as a Google search? That sounds a bit daft, doesn't it? Has anyone tried that? Yes. You have, excellent. Well, you'll know what happens. Not only does Google return the answer, but it also gives you a calculator. You could go on calculating with that number if you wanted to do so, and it's quite impressive. But we can go a bit further. What we've done so far is we've just been looking at the volume. We haven't actually done the entire problem. So let's just sort out the rest of the problem. We know what our volume is. We know this formula. This gives us the formula of the volume of a sphere. It's the volume 4/3 of pi r cubed, where r is the radius. And if we substitute in our number, and then we do a bit of rearrangement, we get this thing. We've got the diameter is equal to 2 times the cube root of 3 times 642.407 divided by 4 pi. So we've now got the whole thing reduced to one calculation. So what could we do with that? Well, what if we typed it into this search engine, this one that is called Wolfram Alpha? What if we said this? Diameter of a sphere of volume 642.5. Now, we haven't told it about formulas. All we've said is diameter of a sphere of volume 642.5. Haven't given it any other clues. What does it do with it? It brings back the answer. And you can see there that it says the result is 10.7. So not only has it understood the text, it's also recognised we're talking about spheres, it knows about spheres, and it knows what the relationship between the radius and a sphere is. And it's done the whole thing for us. Can we get any better than that? Well, what if we type this into Wolfram Alpha? Solve 4/3 pi r cubed equals 12.5 kilograms divided by 19.5 grams per cubic centimetre for r. Now note, here we've done something that you're warned about not to do at school. We've mixed up units. We've got kilograms in there and we've got grams in there. What's he going to do with that? It is going to give us the right answer. It's understood textually what we're doing, and it's this time it's done the complete calculation. Now, we've had to break it down a bit. We've had to help it a bit. We've had to explain a little bit how to do it. How far are we from doing this? 50 years, we have gone from hand calculation to computer-supported calculation. Computer, if a gold bar was recast as a sphere, what would its diameter be? If you mean a standard gold bar, then the diameter would be 10.7 centimetres. And that's happened in my lifetime, and that's where I think we're going, that you will have very soon the ability to put this generic type question to a computer and have the answer back. And hopefully we will then have this. Thank you very much.